In this video, we look at another example of using the molarity equation in combination with balanced chemical equations. The particular problem we're going to look at is expressed here. What volume of a 0.25 molar hydrochloric acid solution is required to exactly react with 15 grams of aluminium? Now, with all these solution stoichiometry problems, we need to start with a balanced chemical equation. So we've got hydrochloric acid plus aluminium metal. This particular reaction happens to be an acid plus reactive metal class of reactions. We can rule out it's not an acid plus base, there's no base there. It's not an acid plus carbonate, there's no carbonate. Not an acid plus sulfite, it's not an acid plus sulfide, and it's not a precipitation reaction. We haven't got two solutions there. We've got the acid and the metal, and by a process of elimination, we've got an acid plus reactive metal, and we know that the products of that are a salt and hydrogen gas. So we're able to write down one of those products straight away, H2 gas. And in order to get the balanced chemical equation here, the trick is to work out the identity of the salt. Now, you'll recall that an acid plus reactive metal reaction is a single displacement reaction, and in effect the metallic aluminium is replacing the hydrogen ion to produce the aluminium chloride salt. And remember, a salt is an ionic compound. It's a metal and a non-metal. The metal comes from the aluminium metal, and the non-metal chloride is the anion of the acid. We have to look at this chemical formula for aluminium chloride and ask ourselves, is this the correct chemical formula for aluminium chloride? Well, the aluminium ion is always 3+. Aluminium is in group 3A of the periodic table, and the chloride ion is always 1-. So they're not going to come together in that 1-to-1 ratio that we've got written up there at the moment. If we do our crisscross method, we'll take the 3 from the aluminium 3+ charge and put it down as the subscript for the chloride ion, and we'll take the 1 from the 1- charge of the chloride ion and put it down as the subscript for aluminium. So when we do our crisscross method, AlCl3 is the correct chemical formula for aluminium chloride. So we'll write that in there. Next thing we have to appreciate is that this equation is unbalanced. We've got one hydrogen on the left-hand side, we've got two hydrogens on the right-hand side. We've got one chloride on the left-hand side, and we've got 3 chlorides on the right-hand side. So we can go through and balance this equation, and when we do, we find that 6 HCl's plus 2 aluminiums plus 2 aluminium chlorides plus 3 hydrogen gas ends up with a balanced chemical equation. The last step here is to get the subscript of the salt. All chloride salts are soluble in solution and will have the AQ subscript, with the exception of silver, mercury and lead, and this isn't one of those, so we're going to have the AQ subscript there for the aluminium chloride. Okay, so we've got our balanced chemical equation. It's best now just to look in some detail at the question and ask ourselves, well, what information have we been given? We've been given 15 grams of aluminium. We've also been given the fact that the solution of hydrochloric acid is 0.25 molar, so its concentration 0.25 moles per litre. And then we've been asked to find what volume of that hydrochloric acid solution is required to exactly react with the 15 grams of aluminium. So we'll use this diagram here as a guide again, and it turns out that this is the relevant part of the diagram. We are going to go through step 1, step 2 and step 3 in this Z-shaped fashion. We're starting with, we've been given information about the mass of aluminium, and we've been asked to find out information about HCl. We've been asked to find the volume of the hydrochloric acid solution. So we'll start with our 15 grams of aluminium, that's the mass of aluminium, and in step 1 we're going to use molar mass information to calculate the moles of aluminium. Step 2, we're going to calculate the moles of hydrochloric acid based on the ratio of the stoichiometric coefficients in the balanced chemical equation. And then finally, in step 3, we're going to use the molarity information to work out the volume in litres of our hydrochloric acid solution. So step 1, moles of aluminium equals mass on molar mass. So that's using our old molar mass equation, and we've got an expression there, 15.0 grams over 26.98 grams per mole. So this information, 15.0 grams, it was given to us in the question, and this information about the molar mass of aluminium we take directly from the periodic table. When we plug those numbers into our calculator, we get 0.556 moles of aluminium. So step 2 now, we have to calculate the moles of hydrochloric acid based on the moles of aluminium. So the moles of HCl, hydrochloric acid, will equal 6:2 times the moles of aluminium. The 6:2 is the ratio of the stoichiometric coefficients. The stoichiometric coefficient of the substance you've been trying to find information about divided by the stoichiometric coefficient of the substance you've been given information about. 6:2 times 0.556. The 0.556 was what we calculated in step 1, and when we plug that into our calculator we get 1.67 moles of HCl, hydrochloric acid. Step 3, we now need to find the volume of hydrochloric acid. So we use the rearranged version of the molarity equation, litres equals moles over molarity. Remember the molarity equation, molarity equals moles on litres. I can make litres the subject of that equation by saying that litres equals moles over molarity. So litres equals moles over molarity, 1.67 moles of hydrochloric acid, that's what we just calculated in step 2, and 0.25 molar hydrochloric acid, that's the information that's been given to us in the question. When we plug that into the calculator, we get 6.7 litres of hydrochloric acid. So in summary, 6.7 litres of 0.25 molar hydrochloric acid is required to react exactly with 15 grams of aluminium. Now just remember, each of these solution stoichiometry problems, there are 3 steps that we need to go through. We're normally given information about one substance, substance A, and we're asked to find information about another substance B. Step 1 is to calculate the moles of A from the information given about substance A. Step 2 is to calculate the moles of substance B using the ratio of the stoichiometric coefficients from the balanced chemical equation. And then step 3, we calculate the quantity of B, whether it's mass, molarity or volume, based on the moles of B that we determined in step 2. If we're finding mass, then we use the molar mass relationship. If we're finding either molarity or volume, we're going to use the molarity relationship. This diagram here, very, very useful in looking at those 3 steps and exactly which way to go. So we're going to be given information about one substance, substance A. We're either going to be given mass information or we're going to be given volume and molarity information. Either way, we now know how to calculate the moles of substance A. So that will be step 1. Step 2 is to convert the moles of substance A into the moles of substance B using the ratio of the stoichiometric coefficients. Then depending on what it is we're being asked to find, we can either use molar mass information to find the mass of substance B on the left-hand side, or we can use molarity information to find either the volume or molarity of substance B on the right-hand side there.